What's up guys, Daniel here. In today's video, I want to show you how I made a floor in my game where you have to pick the right sequence of elevators to proceed to the next floor. So the main idea is, as you can see, there were 3 elevators there, and I had to pick them in the right sequence to go to the next one. So as you can see, I picked one, and then I'm back at the same floor. And I picked the right one, so there's like a little, LED turned on, and then if I pick the next correct elevator, I go back to the starting elevator. There's some transition time. Then another green light would show up, as you can see, and if I pick the final correct elevator, we're back at the starting elevator, as you can see. And if we go out right here, you can see all of them are now turned green, the elevators are gone, and there's like something here. So let me just show you how I've done this, how you can implement also something similar to this. So let's get right into it. Before we get into the game, quick shout out to myself. This is all for a game I'm making. It's called The Final Shift. You can wishlist it now on Steam. It's a horror game where you play as a night janitor in a building, haunted by its history. It has some weird history going on, some story, and some plot twists at the end. I think it turned out pretty nice. It will be soon out on Steam, so soon you can also buy it. It's pretty cheap. It's like $4.99. So you can wishlist it if you want to. Getting back to the video. Alright. So first of all, I have my setup over here with the map and everything, the 3 elevators. And I have these 3 little lights. So the main idea here is that the player goes into one of these elevators, they close the doors, then I teleport them here. So I just change their position, rotate them by 180 degrees, and then do some updating. What is the correct elevator, and then turn on the correct lights, and so on. So let's see how this is done in code. So each of these elevators, as you can see, has their own scripts, and all is happening here is that these are not important right now. What is important is this function when they interact with the elevator. So what's happening, we just have some checking here. If we're in the elevator or if we're already transitioning, then we just return. And all we are doing here is we toggle the door, and we also toggle the door of the main elevator or the one that we're teleporting to. So we close the door, and we also close the other elevator's door, so it will seem seamless when we're teleporting. Then there's a bit of timeout. And you can see that there's a bunch of comments. Yes, I've used AI here because there was so many problems I will tell you about a little bit later. Then all we do is we basically see where we should teleport the player. So we calculate this target transform. So the data that we have here is, here's the elevator marker. This is basically this point over here, so the other elevators, where the other elevator is. But the thing is that the player might be like right at the edge of this elevator. So if I just teleport him to that position, instead of being right here at the edge, he'll be like snapped back to the middle, and that wouldn't look very nice. So with the help of some linear algebra, which to be honest, I'm not sure how this is work. I asked the AI to help me with this, but we calculate this offset so relative to the middle of the elevator where the player is. We calculate this offset, and then we add it to the other elevator's middle point. And then we have our target transform. Then we rotate the player by 180 degrees. The reason we have to do this is because when the player is looking, for example, at the door, if we just change the position, so if we just go here, then the player now will be looking at the back of the elevator instead of the door. So we just rotate him 180 degrees. We teleport the player, so we change its global transform. Probably global position would have been also enough here, but I'll tell you a little bit about this later, and that's basically it. I'll tell you about in just a bit about what all of this stuff here is, and then what we do, toggle the door. So we open the door on, why am I keep tabbing? We open the door on this elevator, so when the player leaves from here, the elevator is once again opened, and then well, basically that's it, and we emit a signal that this particular elevator was chosen. And we use this signal right over here. This is where we're connecting to all of the 3 elevators signals. And here, this is where we check if was this the right elevator in the current sequence. And the way I do this is I have a correct pattern here, which is just an array with some integers, and where we are currently in that array. So we start right here. And then we just check, for example, elevator 2, which is the correct one in the sequence right here. We check, okay, elevator 2 was chosen. Where we are currently, should this elevator be pressed? I mean, is this the next current pattern? If so, then we turn the light green. So I have an emission on it with a green light. I just enable it, so now it will glow in the green. And then I move towards the next index. Otherwise, if this was not the correct one, so the player guessed wrong, we go back to the beginning of the sequence, and then we reset the lights. Basically, I just loop over the lights and disable the emission. Another thing that I do here is, okay, what if the player finished the sequence? So if the last light is also turned on, you can also check this by, if the index is exactly at 3, but I checked it, if the last light was also turned on, then I call the puzzle done. It's pretty ugly, using all of these. I could have also saved these, in a variable, but since this is only executed once, they won't be really needed anywhere else. I just fetched them, each of them, in this execution. So what this does, if you don't know, this is basically just get node. So this is basically get node if you do it like this. And we free the elevators, we show that little table, and we enable the collision shape. And that's basically it. Now, what was all of this stuff that you saw? Let me just show you. All of that stuff that you saw over here. But basically, let me just bring up Paint. Basically, what's happening here is that I have something called physics interpolation enabled. And what this does is that if the engine sees that our player is over here, and in the next position he's going to be over here, he will smoothly transition between these two states. So he might, stick in another frame where the player is over here, so that the transition is smooth. So basically, it's interpolating between these 2 points. But when we're teleporting, we don't want this. So we don't want a smooth movement. We just want the player to go from here to here, no smoothing effect. And the problem here is that we have to tell the engine, okay, stop the interpolation for a second. Because otherwise we would have this and this. We want the player to teleport from this position to this position, but the physics interpolator system would also stick in a frame here, and you will get this this little frame flash between the teleportations. So to fix this, we just need to disable physics interpolation. So that's exactly what we do here. Well, there was a lot of problems, So I have done something like this to reset the interpolation recursively. So here what we do is we start at the base node, so the player controller, the root node. And then if we check this is node 3D, we reset the physics interpolation, and then we go over recursively of all the children of that node. This might be a little overkill but there were just so many problems. I just fix the problem by, shooting at it with a cannon. And then what we do next is we also force update transform. So if we look at it, what this does is that it says that for performance reasons, transform changes are usually accumulated and applied once at the end of the frame to update propagates through to the children as well. Therefore, use this method only when you need an up-to-date transformation. I'm not exactly sure what this does, but basically it just updates the position instantly, so it forces that update, so there's no like a little lag in between the teleportation. I just played around with these, see what worked. And then next we do the same for the camera, and since I'm using a phantom camera here for the player, that also has some damping effect, and I was thinking that might also be the case here. So I also force updated this, and the phantom camera has this teleport position that is exactly for teleporting the player and things like that. So it says in the description, bypassing the damping process. So yeah, that's basically it. And then I do the same thing for the main camera also. I just threw everything here at this teleportation, and it's still not perfect. You might have seen that there's still some kind of like jumping of the camera, but it's good enough for me. So that's basically it, what I wanted to show you in this video. Thanks for watching yet again. If you're interested, the final shift is out on Steam. You can wishlist it, and it will be soon out. And it's not going to be expensive. It's only going to be like $4.99. So you can wishlist it on Steam. I would highly appreciate it. So yeah, that's about it for this video, and I'll see you in the next one. Goodbye.